Really good evening, everyone. And my name is Ovang Vishnavi, and I'll be taking the today's lecture. And let's wait till 6:05 for some students to join, and then we'll start. Right? Okay, so really good evening, everyone. My name is Umang Bishnoi, and I'm the senior course developer for Elite Techno Group. And this is our second day of the bootcamp, and I welcome you all to this bootcamp. So, for those who missed yesterday's bootcamp, I just want to give you a heads up that we studied about the PLC, and we studied about the various programming, ladder logics that that we are going to be implementing today. So today I'm going to do a case study, which is actually height sorting station, and we'll be seeing how the Factory and the WinSPS software works. Okay, so Factoryio is actually the simulation software that that you'll be working on, and the WinSPS is the software that is used for the programming languages. Okay, so you guys must have received the download link for these two softwares. Uh, I would need some answer that have you all received the links?
Yes, sir.
Okay, that's really good. So we'll be learning to how to start the software and how we have different scenes in the software and how we can have different lines, right? And that this software Factory IO software, we can actually use this to simulate and build the whole of the industry, right? So actually, the warehouse automation is really a big thing, but it is just a combination of various, NONCs and the ladder logics that we covered yesterday. And let's get started. Okay, so my screen is visible, right?
Yes, it is clearly visible.
Okay, okay. So this is the software, but we'll start from the very beginning. Okay, so these are the those basic applications that you will be starting. So this one is the Factory IO that that you'll be simulating. So let me give you a demonstration of how it works. Okay. So let's say this is the main screen of how you will be opening it. So we'll be, after this bootcamp today, we'll be sending you some files so that you can load that, that project that I have made for you all. And, to get started with a new project, we click on this new button. Okay. So this is the basic, basic vision, basic, application of how this Factory IO is. These are the few components in the right hand side. As you can see that you can implement, as we have various cartoons, and then we have various conveyors, and we have various robots, actuators, sensors, limit switches, and emergency buttons, and these things. So Factory IO has this beautiful thing that they have some pre-defined scenes. Okay, so we'll be doing one of those scenes that I've created for you all. Okay.
So is this session recording?
Yeah, this session is being recorded.
Okay, sir.
Okay, so this is the sorting station that I have made, and you can get these different kind of station. Uh, this is on the top hand left corner. There's this welcome window. Okay, you click on it. You have scenes. You can click on this, and then there you have different scenes. So filling tanks, queue, buffer station, automated warehouse, and level controls, production line, sorting by weight. So with coming bootcamps, we'll be starting off with the very basic. So to give you a heads up of how this basic software works and how the basic functioning of these software works, right? And this one that the scene that I have created is to give you an. It is although a very complicated system, but just to give you a glimpse of how this works, we'll be studying this, right? So this is about the Factory IO. Okay, now coming to the WinSPS software. So, this is the home screen that you get as soon as you click on the WinSPS software. Okay, so to create a new scene, click on the create a new solution. Okay, now you name it as anything. Let's say we name it as BootCamp. Okay, and we create this. So let's let it go. So this is the screen that we get. Okay, so we'll be clicking on the the OB1. Okay, so we get this where we can design the ladder logic. Okay, now we click on the ladder logic, and these are the on this cursor, these are NOs, NCs, and the coils. Okay, so yesterday, if you guys remember that I was designing some coils. Okay, we were switching on lamps, we were studying about the OR gate and the NOR gate and the NOT NAND. So we are going to be implementing those today, right? So now first coming to the Factoryio software. So we'll okay. So as soon as you let's get this. Okay, so this is the basic conveyor. Now to program it, you need to since this is a simulation software, you need to define different PLCs, that which PLC it is working on. So you guys should make a note for this because you'll have to do it yourself after today's bootcamp, and you'll be doing this project on your own. Okay. So you can align those assign those different values to different IOs. We click on the file button and we click on the drivers, right? Now, these are the various PLCs options that we can get. But since we don't have a PLC, we are using this on our laptop or computer. This is the online PLC that we get. Okay. So I is the input and Q is the output. Okay. So sensor is the input that some kind of sense it is getting, and the conveyor is the output for these these scenes. Is there any doubt so far? Am I audible?
Yes, sir.
Yes, sir. Yes, sir.
So it is clear, right? This
Yes.
is just a basic system. Just to give you give you a glimpse of how these different things works. Okay. Now coming back to that actual scene that we were studying. Okay, that I created for you all. Now I have assigned the values, before this bootcamp. So these are the various inputs that we get. That we have the start, stop button, reset button, emergency stop. Then we have various retro reflective sensors. Okay, we have auto manual. Auto manual are used in the industries in the case when there's a fault that occurs. So you have to switch it to manual, and you have to drive the conveyor yourself or the robot yourself, right? So at exit is the another sensor. So to know how many sensors and actuators you have, these are the buttons. Okay, so here if you click it, so you can remove the actuator tags and you can install the actuator tags. Okay, so you guys see that this is the entry conveyor, then this is the pusher. Okay, these are the actuators. Okay, so now the sensor tags. So sensor tags are these sensors that are installed, retro reflective sensors. So these are installed here. Okay, so these are going to be this is a height sorting machine. So the parts are going to be sorted according to their height. Right? Is it clear so far?
Yes, sir.
Okay.
Yes, sir.
Okay, so to create an automation system, okay, you need to have the first thing that you need to have is a PLC panel, okay, or the basic basic panel to which is fitted with start button, stop button, and the emergency buttons and the basic wiring. So you in this simulation software you won't be seeing any wiring in this, but since it is pre-wired, So you can just pick and place these stop and push button emergency buttons from this place. Okay, so you can place it here, right? So that is how it works. Okay. Now this is the basic. Wait a second. Sorry. Although in the starting it is very hard to use, but as you get a hold of it, it will be easy for you to use. Okay. Now, can you think of this thing? What is this remover here, and what is the emitter here? What do you think it is? Okay, as soon as I start this, simulation, I get this, a hard box here. Okay, so emitter are the boxes in different size and shape that we'll be getting in as the input, and we'll be sorting these boxes according to their height, and the smallest piece is going to be adjusted here, and then the bigger one, and then the biggest one. Okay, so that is how this basic system is going to work. So these are two conveyors that we have here, and let's see how the PLC wiring is done on it. Okay, the PLC programming is done. Okay. Now to go to that WinSPS system, I'll open my solution. Okay, so this is the ladder logic. These are the networks, different networks that you'll be creating to, execute different tasks. Okay, so first, in the starting, you need to
Sir, you are muted.
Am I audible now?
Yes, sir.
Yes, sir.
Good. Okay, so these are the symbols, because PLC understand those symbols, and these are the inputs and IOs. Consider this as the wiring that is done in the PLC, and these are defined according to the application. Okay, so we have so where can you get these addresses? So let's say that I have inserted the address for start as I 0.0. Okay. Now, how do I know this, that the address of the start symbol is I 0.0? So I go to this place, I go to the file, I go to the driver, okay, and I see this PLC. So these are the different addresses that I have defined for these things. Okay, so I can remove and replace it with something. Okay, so that is how it is done, right? So you can, the first thing that you have to do as soon as you open the WinSPS software is that you have to, enter all these symbols manually. Okay. So I is going to be the input, and Q is going to be the output. And since we are not using any counters here, because this is an introductory session of to get you this hands-on. So we are not going to be using many commands, but we are going to be using some of on delay timer, and the basic NC and NO connections, right? Is it clear so far?
Yes, sir.
Okay. So the first thing that you do in a network, okay, so these are pre-made networks. Let me draw a new network for you all. Okay. Okay, so I'll be doing this ladder. Now let's say that, suppose let's talk about the other day example. Okay, so we were trying to switch on a lamp with the start button. Okay, start push button. Now the first thing that you need to have is a NO connection. Okay, so this is the NO connection, as you can see here, and you can just click it and drop it here. Okay, and this is the question mark that you are getting. So it it does not install the addresses themselves. So what you do is you click on this and you write I 0.0 and enter. So it is going to define the name of the button itself, since you have added this in the symbol table. Okay, I've added the start as the I 0.0. Okay. Now so what was the second thing that to switch on the lamp? We had to enter a coil. Okay. So we'll be picking it up and dropping it here. Okay. So this marks the end of the this ladder. Okay. Now what we are actuating is going to be defined by Q. So let's say that we are trying to start the entry conveyor here. Okay. So I'll be clicking this. I'll be writing Q 0.0. And this entry conveyor is there. Okay. Is it clear so far? This is the basic ladder logic that you'll be creating.
Yes, sir.
Yes, sir.
Yes, sir.
Right. That's very good. Okay, so now this WinSPA software is more than just the these basic ladder logics. Okay, so you need to as soon as you make these networks, you have to install it to the PLC. Okay, which PLC is the actually is the Factoryio. So these WinSPA software and the Factoryio are interlinked. So in different software, if you go in the factories, you have to first connect the computer with the PLC with the Ethernet cable, and then it recognizes the PLC, and then the software is installed. But since that hassle is not here in the simulation software, so we'll not be doing that, right? So now coming to this software, now how do I know that this software is working really good? Okay, so there are no faults occurring, and my the ladder logic that I have created is working perfectly. So how do I know this? It is here in the right section, the monitoring. Okay. Okay, so I'll save the block first. So as soon as I click on the monitoring, so this is the pink line that you are getting. Okay. Just hold on. Okay, I'll start this software. Okay. So now what does this pink define? Pink defines that the current is going to be passed from here if the current comes from this place. So consider this pink line as a current. Okay. So we were talking about the circuit yesterday, that as soon as the circuit is closed, the current passes, and different lamp is switched on, or different task, different application that we were thinking of. Okay. So let's come to the Factoryio software. Okay. Now, wait a second. Okay. So now to start the whole basic conveyor and this application, the first thing that you need to press is the start button, because it is the NO connection, and it needs to be pressed so that the current starts flowing. And we have taken a latch here of the entry conveyor, and then the emergency stop and the stop. Okay, why do you think that I have taken the emergency stop and the stop as NO and not NC? Can anybody define this? Come on, guys, I'll be needing your input. What do you think? Why do you think that I have taken the emergency stop as NO and not NC? Am I audible?
Yes, sir. So it will
Yes,
be
sir.
open only for now. Like
Yes, sir.
whenever we need to cut the circuit, then only it should be closed.
Yes, actually. So when emergency stop and the stop button is designed, So emergency stop button is designed in such a way that, as soon as you press it, as you can see on this screen, as soon as I press this emergency button, okay, it goes in and it stops there. Okay. But whereas I as I press this stop button, okay, as soon as I leave it, it comes to the NO connection, NC connection. Okay. So, and stop and the emergency buttons are designed in such a way mechanically that you don't have to take a NC for these buttons in the software. Okay, that is why these softwares are in the software we take this emergency stop and the stop as the NO connection. Right? Is it clear?
Yes, sir.
Good. Really good. Now, let's simulate this first, and we'll get on the second network, third network. As soon as the circuit goes. Now, to start this whole software, this simulation, we'll click on the start button. Okay. Now, what do you think was a change in the circuit as soon as I press the start button? Okay, just see it again. As soon as I press the start button, what happens? Can you all see what happened there? So the current, I'll tell you. So the current started flowing, and since we took the entry conveyor, the latching of the entry conveyor here, so we had this coil of entry conveyor here, and as soon as the these boxes started to go, the latching connection was done. Okay, and the circuit was completed. Is it clear so far? I mean, it is a little. It is
Yes, sir.
a little. It is a little hard, but these are just basic NO-NC connection. As we were drawing it on the screen or drawing it on the paper, it is same as that. But so there are some added options to link this Factoryio with the WinSPS. Okay, so that is why we have to define these symbols first, and then these symbols can be used in the ladder logic, right? Okay, so let's see how the system is working. Okay, then we'll come to that software. Just wait a second. Hold a second. So the box starts to come, and this is the first conveyor, and it goes on to the second conveyor, right? And these boxes are sorted according to their height, right? And it goes to the side, and it is removed from the place. So this is how the sorting is done. Okay. Now, as soon as this box comes, it will start going again, and this box is going to be sorted at this place, and then different sizes are going to be sorted accordingly. Okay. Now, think of the situation. Okay. So as soon as you start writing codes, you need to first write down what the problems are. Okay, what we need to define. Okay, so first sensor that we are going to get. Okay, so we have placed this sensor here. Now it needs to have some delay. Okay, so as soon as the box reaches to this place, so that the pusher actuates and it is removed from the place. Okay, so these are the functions that you need to write down, and that is how you design this. Okay, so the first problem that we were facing was to start the whole system. Okay, so we started the whole system as with this start. Okay, just ignore these T0, T1, T2 for now. Okay, we'll be discussing it as soon as we go on to the next networks. So just think of this basic system as start, emergency stop, stop, and the entry conveyor, and then there's the latching. Okay, this will start the entry conveyor. Right? Is it clear so far?
Yes, sir.
Okay, good.
Yes, sir.
Now coming to the next network, as as soon as the entry conveyor is actuated, what will happen now? So this is the on delay timer. Okay, so where can you get this on delay timer? Wait. So you go to this. Let's close this filter. Okay. So this is the catalog that you get, okay, on the left-hand side. So these are the various conditions that you can use in the software, and we'll be studying all these in the coming boot camps, but not now. So we'll be only focusing on the on delay timer here. So timer, as you can see, it is at this place, okay, and this is the the on delay timer. Okay, so this is written in German, but it is actually the on delay timer. Okay, so you can pick it up and place it here. Okay, so now the sensor big box. So as you saw that the sensor big box is at this place. Okay, it is at this place, right? Can you say her? Okay, so it is at this place. Now, as soon as that sensor starts to, is actuated, okay, as soon as it turns to NC, it will actuate the timer here. Okay, as soon as the timer is actuated, this is this section. It is written in this format, and I can change it according to the need. So let's say that wait, S5T1S. Okay, so 1S defines the, just ignore that S5T because this is the basic protocol, that we use to write the, timer. So 1S is the 1 second. Okay, so on delay, delay will be given, and then the actuator will actuate that, that pusher that we were talking about. Okay, so as soon as this box passes from here, it will wait for 1 second, and then the pusher will actuate. Right? Are you understanding, guys?
Yes, sir.
Okay, it might be a little
Yes,
tough.
sir.
It might be a little tough, but the project that you'll be getting after this bootcamp, you need to have this basic clarity because these ladder logics are nothing more than this programming. Okay, you need to have basic, logic to, actuate these. Even at this stage, even after so much of experience, I also, get stuck in between because, then, conveyor starts to work, but actuator doesn't work. But as soon as you keep on making some more programs, you get a hands of how to do this. Okay. So as soon as the sensor big box is receives the signal, it turns into NC. The timer starts to function, and the pusher big box is actuated after 1 second. Okay, and in the same way, it is also actuated here for this small box, and it is actuated for the medium box. Okay, so let me give you an example of how you can insert the timers. Okay, let's say that this is the ladder logic. Just I'm randomly defining those, and you don't have to focus on it that what it will do. So I get the start button here. Now I'll insert the timer here. Okay. Okay. So now the first thing that you need to do is define the name for the timer. Okay. So over here we have defined the T2 timer, T1, T0. Okay, it starts from T0. Now we can name it as T3 maybe. Okay. So the name of the timer is designed now. Now you need to have the how much on delay you need to give for the actuator to work. Okay, so for this application, I only needed a 1 second delay for this box to reach at this place, and the this this conveyor to stop at this actual place, and thus the pusher starts to function. Okay. So this is the delay that is given in seconds, and then what is the actuation that you want to get done with it? Okay, so you can place it at Q. Okay, I'll. So this is the this it can come to the second line. That's okay. That you don't have to worry about that, and you can give the name of this actuator as anything like the actuation that you want to get done. Okay, so that is how the timer you can install the timer in this section. Okay, now how to reset the timer, that is another thing that we are not going to be discussing today. But this is how you get this timer installed. Is it clear so far? Please put up any doubt, because this is very hard topic, and you need to have a basic understanding, because this is the core of these ladder logic programs. Please put up any questions if there's any doubt. Is it clear all?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, that's good. Okay, so this is how the we design the basic ladder logic, and let's to get a hands of it, that how this sorting station works. Let's do the actuation of this. Okay, so we get this, we start the monitoring. Okay, and we go to this software, stop it, and we play it again. Okay, so the part comes at this place. We start the operation by clicking the start button. So this is the smallest part of all, which we are getting on this conveyor. And just look at this retro-reflective sensor here. So this is for the smallest parts of all. Okay, so now why do you think that the obstruction was done here? Why didn't this box go into the remover here? Now tell me, can you explain, anyone?
Sir, because of its large size, so sensor will detect that the box size is larger. That's will it will remove from the conveyor.
No, that is not the reason. Can anybody else tell me?
Sir, delay was not given properly at that time.
Sorry, what was not given?
A delay while it's moving.
Right, actually. Okay, so the thing is that this is the big box. Okay, so we name it, we can change the names here according to our need, and to make it easy for us. Okay, we can change its name. So that is why I've named them as pusher front big, then pusher 2, and these things. Okay, now coming to the software here. Okay, so this is the big box that we were getting. So we took that delay as 1 second. So the 1 second was not enough for it. Maybe we need to give 1.5 seconds so that it comes into place and actuation can be done. Okay. So this was the problem, that we need to change the delay on this. Okay. So let's change the delay now and let's see how it works. Okay. So we are going to close the monitoring. S5T Ash 1S. Now, what do you think? Why do you think that I have given this 50 ms here? What do you define by this 50 ms?
It is milliseconds.
Yes, actually. So 2 seconds will be so much for it, and then 50 seconds might not be enough. But we can. It is a hit and try. Okay, so actually this software was designed. Factoryio was designed so that, because in actual factories, this this fault that was occurring, the box that that was stuck here, it can cost the factories a huge amount of money. Okay, this might damage the pusher, it might damage the box, or might damage the crucial thing that is in the box, or it can damage this slide here. Okay, it can damage various things. Okay, so this factory IO was designed so that less damage can be done. Okay, so let's name this S5. I think that it is going to take 2 seconds. So let's say that 2 seconds is done. Okay, we'll upload this. We'll send all lecture blocks. Yes, override. Now let's monitor it again and let's run this software. So these are the smallest of all, then these are the medium sized box, and these are the large size box. Okay, and the sensors are placed according to that only. Okay, now the actuation is done correctly here, right? But what did this cause? Okay, this caused the malfunctioning of this product. Okay, so we don't need to change the programs for it, because the feeding system that we are getting, we can also change the timing for that. Okay, we can click on right click on it, uh, and let's say that next time that we can put it at 3, and it can be done according to our need, so that parts you are fed very slowly for the actuation to work. Is it clear?
Yes, sir.
Right.
Yes, sir.
Okay. So, let me interrupt in between. So, these are the faults that might occur as soon as you start working on these softwares. Okay, but you don't need to worry. These are, basic logics that, mess up with mess with our brain. And, the answer is right in front of us, but we can't see it. Because, if I would have, think this was correct and this is not going correct, so that is because maybe the feeding is not being done correctly. Okay, we made this this delay thing right, but the feeding was not done properly, and that is why it was stuck in here. Okay, so these are the basic basic problems that occur during these software, right? So let's just actuate this and we'll move further. So this is the basic actuation that is done. Okay. I hope this software and the Factoryio software and how you are going to interlink this and how this ladder logic is created, you can draw this. You understood all this, right? Is there any doubt? Please put up if there's any doubt, because this is the crucial ladder logic that you will be studying in the later boot camps. Okay, so if there's no doubt, let me so let's switch to the project that you will be doing today. Okay, what will be the agenda of the project? And we don't we you will have to program the software in the Win SPS, and you'll have to run it, and you can click a screenshot of the ladder logic, and you'll be uploading those screenshots in the link that our marketing team has sent. Okay, so let's go to that software that you'll be programming today. So this is the filling tank operation that you'll be doing today. So you'll be using some timers in it. You'll be using the basic, these buttons. Okay, I'm not going to tell you how to, program this in the WinSPS software. But let me tell you how this is going to work. So the filling of the tank and the the discharging of the tank. Okay, so that is you can that is hit and trial. Okay, so how much it is going, how much time it is going to take to fill to this place. So this is just hit and try. Okay. So I've what I've done for you is I've made this project simple for you. So in the drivers option, as we go, so these are predefined. So you don't have to do anything in this. You just have to open the WinSPS software. You have to enter it in the symbol table, and you have to create the ladder logic. Right now, after creating the ladder logic, the first thing that you need to do, because it is not going to upload itself in the Factoryio, because these are two different softwares, right? Now, how do we do this? Is, as you must have seen that during the project itself, I was doing it. So I click on this PLC. Okay. So look this. So it is not going to upload in the monitoring position, monitoring state. So first we have to close it. Okay. Then we click on the PLC. We click on the send active block. We overwrite the block OB1, and that is how the software is uploaded on the Factoryio. Right? It's simple. Any doubt?
No, sir.
Okay. So you don't have to understand what this discharge valve is going to do. You don't have to understand what this fill valve is going, how much pressure it is coming from, or how much this is. You just have to program the basic structure. Basic, to give some timers as soon as you press this button, and that how much that at what time it is going to stop, and then you have to click on the discharge button, and then how much time it is going to take to discharge. Right. So I'll be sharing some link in the comment box today, and as soon as you fill the feedback form, you'll get the this saved file, and you can open it in the Factoryio, and then with the WinSPS software you can program it, and you can upload that ladder logic in the sheet that we have given you, and in that that is how you will get the certificate for this book, right? So this was the whole basic idea of Factoryio and WinSPS, and I'm open to question now. So I guess this is the end, and there's nothing much to learn about it in this software. And please put up if there's any doubt.
Good evening, sir.
Yes.
So, thank you for the session. And like, I want to ask you about like if we have like 3-4 sensors,
Right.
be it like a pressure sensor or a vibration sensor, accelerometer kind of thing, and we're using it in a motor in a factory, and like there are 50 motors, and we put accelerometer in each of them, and then we connect all of them. Like, can we get the data in the computer where it can monitor the vibrations?
See, I'll tell you about this. So, in the actual conditions, okay, let's say that you are working in a factory or in an industry, okay. So these things are possible because you have the actuators that are going to work. You have the PLC that is connected to the computers, and you have the IOs, different IOs that actuators are connected to, and the inputs are connected to, right? But in this particular software, the Factoryio, wait, I'll share my screen again. Okay, so as soon as you go to this software, okay, and you click on this, wait, wait, let me open a new scene. Sorry. Because my laptop is working a little slow. Okay, so it is not opening now, but as soon as you click on this palette window, okay, so you get the different actuators that I was showing you. Okay, so in this software, these actuators and the sensors are limited, and thus I'm giving you these basic programs. But if I go very deeper into that, as I was showing you that height sorting station, okay. So if I ask you to program that, it is going to be a little difficult because you need to have to get an understanding of how the reset is going to work in the timers. Okay, then you need to understand the NC connection that we were taking for the timers in the first network, right? So as the more thing that you add, it is going to become a little complex. Okay, but we are going to start off with really basic, right? So we are going to take step by step to the next level. Okay. So as you were saying in the factory itself that we can include the accelerometer or different kind of sensor in one thing. Yes, it can be possible, but in the physical condition, not in this software because the application of this software is limited, right?
Okay, yes, sir. But like so, in the application point of view, if you don't talk about the software, so we just connect them and write a PLC code and just
Yeah, see, let's say that you are using the accelerometer for sensing some speed of the object. Then you were talking about some different sensor. So you can the sensors are going to be the input, okay, and these sensors are going to the signal is fed into the PLC, the the program that we have designed it for, and those sensors are used for the actuations of the devices. Okay, and the programming is done according to our need. So as I was designing that sorting station program, so I was designing it according to the need that I have to sort these different boxes according to their sizes, right? So that is how this system works. If there's any still any doubt, please put it up.
got it, sir.
Okay, good. So is there any other doubt? Okay, so Biswa, let's open the chat box. So sensor is the feedback input, and the actuator gives the output by actuation. Biswa, you're correct, and that is the sensor senses the change in the environment, physical environment, and let's say that we are talking about a proximity sensor. Okay, so proximity sensor is going to detect some changes in the environment, and it is going to detect if there's any part coming near to it, and actuation is done according to the program that we have made in the WinSPS software. Okay, so WinSPS is not a single software. There are various softwares for different PLCs, and the harsh truth is that if I go for Siemens PLC, I only have a particular software that only the Siemens PLC are going to implement. I cannot use that same software for Allen Bradley. Okay, so that is how it works. Please put up any other doubts. Okay, Biswa, there's your doubt as I can see in the chat box that sensor small box is. Can you please speak up and tell me this question that you were facing? Okay, so I'll read it out. Sensor small box is identified, the small size box, and put it in its warehouse. Sensor medium box is identified, the medium box, and put it in the warehouse. Likewise, sensor big box is working. Yeah. As I was telling you that you can change the name according to your need and according to your understanding. Okay, so you are not limited to some heavy names, some X, Y, cross Z, and these names. You can use simple basic names for the understanding because while writing these codes, it gets a little confusing because there are so many IOs and there are so many addresses that you get confused and you write this one address into some other place, and that is how the program doesn't work. Okay, even I till this at this place I faced this problem, and that is how this was. Yeah, so Emma, as I can see in the chat box, that the software for the download link for the softwares have been sent to you, and you can check it on your email, or as soon I'll share a feedback form. So as soon as you fill all these feedback forms, you'll get the the project that you have to do, the programming that you have to do, and the software downloading links. Okay, wait, I'll share this. Right. So, is there any other doubt if you guys are facing during the programming? Please put up any doubt like you were facing the other day for the NONC or the not gate, NOR gate, AND gate, and the different gates. Or the in the today's lecture that some problem that you were facing. Okay, so if there's no doubt, we'll be winding up this session now. And yes, I can see Virag, you will get the recording. These sessions are recorded, and you can get these recordings later. And the software that you will be making, so you will get some time for it, to get this done. And it will be sent to your email that how much time will you get, and after that prescribed time the form will close, and to get the certificate for this bootcamp you all will have to do the project, and if even if you don't if you are not able to do the project, you still need to get it done, like you need to initiate this thing, because I know it might be a little difficult, and this might seem a little confusing because on the software we haven't done this in the past, and we might be able to do it physically, but it might be difficult in the simulation software. So just try to do it, and let's see how you all perform. Okay. So I thank you all very much for attending this session, and keep learning, keep exploring. Thank you.
Hello, sir.
Okay. Yes, Nikhil.
Sir, the link is open, but it said that the your response is already done. Like
Okay.
you can fill out.
Okay, I'll ask the marketing team to open these forms again, and you'll be able to send the feedback again. Okay, and you will get the download link for the the software. Okay, and the program that you are going to
Okay,
make. Okay.
okay, sir. Thank you.
Okay. So let's wind up now, and thank you very much for attending this session. And we are going to take more sessions in the future, and we are going to go some extensive learning in the PLC. We were stuck on the on delay timer today, but we'll be studying about the bit logic operators and various actuators and some various applications that can be done. Right. So thank you and have a nice day. Bye bye. Okay, I can see that Rahul has raised his hand. Is there any doubt, Rahul?